This video covers Pre-Calc Notes 9.2. We're going to be dealing with arithmetic sequences. Arithmetic derived from arithmetic, so sequences that we're adding the same number to the previous term to get the next term. And then we'll deal with partial sums in the second part of the video. So here's an arithmetic sequence. I know that it's arithmetic because all I'm doing is to get from 1 to 4, I'm adding 3. To get from 4 to 7, I'm adding 3. I'm adding 3 to get from 7 to 10, and I consistently am adding 3. Add 3 there, I add 3 there, I add 3 there. So this adding 3 is something that we're going to call the common difference. The difference between these two terms is 3, the difference between these two terms is 3, the difference between these two terms is 3. And so we're going to come up with a generic formula that we can use to find any arithmetic sequence. Before I show you that formula, I want to show you how it was derived. So if we look at our example here, our first term of our sequence was 1. To get to the second term, to get to 4, what we did is we did 1, the first term, and we added 3 to that. And that's how we ended up with a 4. The third term of the sequence, we took our first term, we added our common difference to get to 4, then you add another common difference to that, and you got to 7. And the fourth difference was the first term plus the common difference to get to the second term, plus the common difference to get to the third term, plus the common difference to get to the fourth term. And so that gave us the 10. So if we think about this, the way that we're actually finding the generic formula is by taking our first term and adding several common differences to it. So our first term we just find by taking the first term, whatever it is, a sub 1. But our second term, we took our first term, which was 1 specifically, so we'll just call it generically a sub 1, and we added a common difference, 1 common difference. So D is going to be the letter that we will use to stand for common difference. Then, to get to our third term, what we did is we took our first term, so our first term here, and we added 2 of these common differences to it. And then, to get to our fourth term, we took our first term, so first term, and we added 3 common differences to it. So that allows us to come up with this formula here. The generic formula for the nth term of the sequence can be found by taking the first term of the sequence, a sub 1, and adding 1 less than the term of the sequence times the common difference. So let me tell you how I got that. Notice in a sub 2, our n value is 2, because it's the second term of our sequence, but I'm only adding 1 common difference. So that's 1 less than 2. In this one, when our n is 3, I'm adding 2 common differences. When n was 4, I'm adding 3 common differences. So it's always 1, the common differences is always 1 less than whatever n was. So if n was 4, this is 3. If n was 3, d is 2. So that's how you can find the formula. Now it's not necessarily important that you know how the formula was derived. What's more important is, do you know how to work with this formula? So this is a formula that's on your formula sheet, and I want you to know how to use that formula. And again, this is the formula for the arithmetic sequence. As we progress through this chapter, we're going to start changing formulas from our patterns won't always be we're just adding a number to get to the next term. So we know that this formula only works if we have that common difference, if we're adding the same number to get to each term in the sequence. So if I want you to write the formula for the sequence that we were dealing with, we need to take the generic form, or the formula. So I'll write it down here for you. And the things that we need to know in this formula are the first term and the common difference. So I need the first term and the common difference. Now we've already found that because we've already looked at this this example, but again, first term would be 1. That's my first term. The common difference is, what do I go from here to here? Well, I'm adding 3 each time, so the common difference is 3. So we'd say a sub n is equal to 1, the first term, plus n minus 1 times the common difference of 3. Well, let's manipulate this a little bit to reduce and combine like terms. If I use the distributive property, we'd get that. Combining like terms, we would get 3n minus 2 as as the formula to find any term of the sequence. Let's just test it to make sure that we did this correctly. So if I ask you to find the fifth term of the sequence, 1, 2, 3, 4, 5, that would be 13 right here, right? That would be the fifth term. That would be when n equals 5. So if I plug that into the formula here, 3 times 5 minus 2, so if I use this formula here, I get 15 minus 2, which is 13. Isn't the fifth term of our sequence 13? So we know our formula works out. Okay, our next example says find the formula for the nth term of this arithmetic sequence. So I know arithmetic sequence has to use this formula as a common difference of 2, so that means my d is 2, and a first term of 5, so my first term is 5. Again, those are the two things that I need, and they give that to me right away, so just plug in 5 plus n minus 1 times 2, multiply in, combine like terms, 2n plus 3 would be the formula to find any term of this sequence. Now I don't have the actual sequence, so I can't plug anything and test it on this one. Next example says find the 19th term of an arithmetic sequence. So a sub n equals the first term plus n minus 1 times the common difference, when I know that the common difference is 6 and the second term of the sequence is 11. So if a sub 2 equals 11, then the first term of the sequence would have to be 6 less than that. So a sub 1 would have to be 11 minus 6, because that's my common difference. So a sub 1 would have to be 5. So remember, to be able to write the formula for the sequence, the two things that I always need are the difference and the first term. So if I'm not given the first term, but I'm given, in this case, the second term, and I know the common difference is 6, just work your way backwards till you get to the first term. In this case, it would have been 5, and now I can plug my numbers in. A sub n equals the first term 5 plus n minus 1 times the common difference. Let's multiply this in. 5 plus 6n minus 6. So it looks like 6n minus 1 would be the formula for it. That doesn't answer my question, because the question says find the 19th term. So the 19th term can be found by doing 6 times 19 minus 1. And that's going to give me 113. So again, when you're using the arithmetic sequence formula, the two things that you always need to know are the common difference and the first term of the sequence. Then you can find any other term that it asks you to find. Alright, taking a look at the next problem, it says you're given the fourth term is 20, and the 13th term is 65, and I want to know what the nth term of the arithmetic sequence is. So again, here's my generic formula. And the two things that I need are a sub 1 and my common difference. Now, I'm not given either of those. So what I'm going to have to do is use some substitution here to be able to find what I'm missing. So if I'm given the fourth term, let's plug that in. So the fourth term is equal to the first term, which I don't know, plus n, which would be the fourth term, minus 1 times the common difference. Do the same thing for, and actually in this case I do know the fourth term. I should replace a sub 4 with what it is, 20. Do the same thing for the 13th term. The 13th term of the sequence, so a sub 13, which is 65, would be equal to the first term of the sequence, which I don't know, plus the n, if this is the 13th term, would be 13 minus 1 times d. So if I simplify this, and I simplify this, now I can use the elimination method when I have two unknowns that I'm trying to solve for. I'm just going to move this one over here. 65 equals a sub 1 plus 12d. And now I can solve this equation by elimination method. Would tell me I'd have to subtract to get these to go away. So this would be negative 45, the a sub 1's would cancel out, equals negative 9, d, divided by negative 9, I'd get my common difference to be 5. Now that I know my common difference, let's plug that common difference back in to this problem here, and I can get my a sub 1. So 20 equals a sub 1 plus, that's really 3, times n, which was, or excuse me, times d, which is 5. So I'd have to, that's 15, so I'd subtract 15. And I find that my a sub 1 is also 5 for this problem. So now it says, what is the formula for the nth term of the sequence? So I can actually find the nth term of the sequence by plugging in the first term plus n minus 1 times the common difference and distributing. Nth term would be equal to 5 plus 5n minus 5. So those would actually cancel out and just give me 5n as the answer. So in this problem, because I didn't know either of these two to start out with, and that's what I needed to be able to write my equation, I have to kind of work from what I do know. I do know that in here my n was 4, and in here my n is 13, and since I know those values, I could plug them in for the two things that I knew in my equations, which would be the a sub n and the n value. Do that twice and use then your algebra, which says use elimination to solve these, and you can find the two things that you needed, a sub 1 and d, and you can go back and write your equation then.